Hi everybody and welcome to school. Today we're going to do a review for pre-calculus. Our pre-calculus review is going to consist of chapter 2, section 1, 2, we skipped section 3, 4, and 5. So, without further ado, let's start with question 1 from section 1. If you'll recall, in section 1 it asked us to solve the equation graphically. So that's the first type of questions that we did. We needed to find the solutions in the given interval. So our interval was over here from 0 to infinity. As you may remember, 0 with a bracket around it means that it includes 0 and goes to infinity. So in order to solve it graphically, and this is kind of nice for your chapter test on Monday, what you'll need to do is you can enter this into Desmos. A couple different ways we can do it, if you'll recall. The first way is to just enter the equation in as it is, I think. Or we just enter it in the left side and then the right side. So x cubed plus 2x squared. And then you enter the right side of the equation in, 11x plus 6. And you see where they intersect. So first we have this point at negative 0.51. But we don't have to count that one simply because it says it's from 0 to infinity. So we're going to look for another point of intersection for these two. And if you just click on it, you can see that it's at 2.764. So that would be our answer. The other way to do those would have been to get it all on one side and see where it crosses 0. So if I just do minus 11x minus 6 and get rid of this other equation. Now if I look at where it crosses 0, it's crossing 0 at 2.764, which is the exact same answer as we got when the two lines were crossing. Like that, yeah. All right, so like I said, two ways to do that. If you look at our second question on this assignment, it says from negative infinity to 0. All right? So if I look back at my graph, from negative infinity to 0 would be everything back here, and I'm just looking at where it crosses the x-axis. So that would be at negative 0.51 and at negative 4.254. So those would be my two answers on that one. If I had looked at it this way, which was our original way, then I would need to find where it crosses. First one here at negative 0.51, and the next one down further. Same thing, negative 4.254. If we look at number 6, this one is far more complicated, but really we just need to put it back into the calculator again. I wish there was a way to copy and paste this in there, but there's not. What I will do though is split my screen. You guys know how to do that? Everyone knows how to do that? You just grab it and drag it to the left side of the screen, and that'll split it. Alright, well, I didn't find out until like maybe 2 weeks ago. A little longer than that. But. Alright, so if I put it in parentheses, 3x to the 4th plus x to the 3rd minus 6x to the 2nd minus 2x. Go outside of the parentheses, do the division sign. You'll see that everything that's in the top is where it needs to be. X to the fifth plus x to the third plus 2. Now I have my graph. And now I'm looking for where it's equal to 0. So did it ask me for an interval from 0 to infinity? So if I'm looking for where it's equal to 0, and click in this spot here, 0, 0 counts because I had a bracket on that side. The next point would be here at 1.414 and 0. And then if I just continue to go out, you're going to see that this forms what's called an asymptote, where it gets closer and closer, and it looks like it's actually on the line, but I can see that there's still a gap. So that's it for that one. There's only the 2 spots. All right. Next type of problem is when we would solve for x. A couple different ways we learned how to do this. We could either factor them, we could complete the square, or we could use the quadratic formula. In these cases, your other option would still be to graph it, but I'm going to tell you to solve it algebraically. If I tell you to solve it algebraically, you have to show your work, simply because I'm looking for one of those 3 types, either quadratic, factoring, or completing the square. So, on the test, I will tell you to do it algebraically. I won't tell you which method to use. That'll be up to you. There will be at least one that you can't factor. So be on the lookout for those ones. In general, how do we know whether we should use completing the square? We can't use completing the square if our coefficient in front of the x squared or y squared is greater than 1. So the only time we can use completing the square is if that's a 1 in front of there. This is a 3, so that's not going to work for us. We could try to factor it. We need to figure out what multiplies to give us 3 and what multiplies to give us 5. Well, that's 3 and 1. And then this is 5 and 1. And then I can do my grouping. So it'd be 3x and x. This is a negative 2. It would be minus 5 plus 1. To check my answer, 3x times 1, that gives me 3x. Negative 5 times x is negative 5x. 3x minus 5x gives me negative 2x, which is what I was looking for in the center. So it's kind of an art form to learning how to factor it that way, especially when we have a coefficient in front of the x squared that's other than 1. Now I can just solve this. Three x minus 5 equals 0. X plus 1 equals 0. Add the 5 over and divide by 3. X equals 5 over 3. Subtract the 1. X equals negative 1. Those would be my 2 answers. If I wanted to use the quadratic formula, the nice thing about it is it works every single time. So, if I use quadratic formula for that, you should remember what the actual formula is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I just plug each of these values in. So negative of a negative 2 is a positive 2, plus or minus the square root. Negative 2 squared is 4, minus 4 times 3 times 5. All over 2 times 3. As you can see here, I have 2 plus and minus. 4 times 3 is 12, and then times 5 is 60, so that's going to give me the square root of 4 minus 60, which is negative 56 over 6. Can't take the square root of a negative, so this should have no real zeros, which means I did something wrong up here. And I found my error. It's when I thought that I could multiply negative 5 and 1 and get a positive 5. That would give me a negative 5. So this would need to be a positive, which means the whole factoring method doesn't work. Which is a great example of why we should use the quadratic formula just about every time. Because sometimes you can make the smallest mistake and it will give you just complete and total incorrect answers. Now I am going to kind of keep that up there for a reason though. So this one would be no solutions. Since you have a lot of time to do these questions on the test, even though I'd be asking you to solve this algebraically, you should try to graph it, and you would have found out it's no solutions right away. Let me show you why. If I do 3x squared minus 2x plus 5, if I look at this, where does this cross the x-axis? It doesn't. So that tells you that there's no real solutions. Should have known that right away. Tragic is what that was. That was tragic. I apologize for misleading you all. All right. Let's move on to the next one. Hopefully it doesn't embarrass me nearly as bad. For the next one, looking at the y, I have to get this 5 over to the other side. So I'm going to do that. 3y squared minus 2y minus 5 equals 0. Now I could try to factor this, and if I do, you're going to find that my original factoring was right up here for a negative. So that would actually be the correct answers for that one. See, I was just ahead of my time. Because negative 5 times 1 gives me the negative 5 that's in this problem. The whole time I was just doing number 10. That's where the problem came in at. Or we could do the quadratic, which is going to be pretty close to the same thing down here. Negative of a negative b gives me a positive 2 plus or minus the square root of b squared, which is 4, minus 4 times a, which is 3, times c, which is negative 5. All over 2 times 3, or 6. Now when I look at this, negative 4 times 3 times negative 5 gives me a positive 60. So it would be 2 plus and minus the square root of 64 over 6. I can take the square root of 64, gives me 8. So 2 plus and minus 8 over 6. And you just do 2 plus 8, which is 10 over 6. 2 minus 8, which is negative 6 over 6. And I get the answers 5/3 and negative 1. And those should be the same answers that I got up at the top. Hallelujah, it worked.